All right, welcome back. Hananiga, Algebra 1, Section 7.7 on factoring special products. The difference of squares is really one that's unique. It's different than all the other ones. And perfect square trinomials is more of a pattern than anything else, but you can factor that in your normal guess and check or grouping method. So here we go. This is a very, very, very specific type of factoring. First, it has to be a binomial, so two terms. The first one has to be a perfect square, it has to be a minus sign, and the second one has to be a perfect square. So if all of those are true, a binomial, perfect square, a minus sign, and a perfect square, it can be factored. So what you do is you take the first term, its perfect square, the second term, and its perfect square. One of them's plus and one of it's minus. Now, if you remember right, we talked about this just a while ago when we did foiling. This is a special type of foiling. Remember, if you have the exact same binomial, one's plus and one's minus, it ultimately cancels out the middle term. So this is the opposite of that FOIL that we did earlier in the chapter. So perfect square for x squared is x and x. Perfect square for 9y squared would be 9y and 9y. And again, one of them's plus and one of them's minus. And it does not matter which one's plus and which one's minus. Next one. Keep it in the same order. So 64 is 8 and 8, D and D, one's plus and one's minus. So don't go ahead and switch it around. Leave it in that order. I know that one seems weird just because the letter came second. The next one, 3M and 3M. 6 and 6 make 36. So again, this is a very specific type of factoring. Binomial, perfect square, minus perfect square. This is also, this one is a little bit different. There is a pattern here. If the first one's a perfect square and the last one's a perfect square and the middle is double the perfect square, then it's actually also a perfect square trinomial. I don't recommend you memorizing that. I would just do this as I would normally do a trinomial. No number in front. So factors of 9 that end up being 6. Now, you can leave it this way, or you could write it as x plus 3 quantity squared. So that's another way of writing the same answer is just the 2 parentheses, or the 2 parentheses since they're the same squared. So the next one, factors of 16 that end up being 8. And again, you get the same binomial, so you could write it as a perfect square. Next one. And this is where the understanding the pattern would make this a lot easier because it's 5x and 5x, 1 and 1, because the first one was a perfect square, the last one's a perfect square, and the middle is a double. I just did this by guess and checks. So I guessed 2 numbers that make 25 and 2 numbers that make 1. That's probably the easiest way, is when you see a perfect square, then probably picking the perfect square. So 9a squared is 3a and 3a, a minus 5 and a minus 5b. And then if I check the inner and the outer, it would work to be the middle. So again, there is a pattern there, but I don't necessarily recommend you memorizing that pattern. This is where we really start combining everything. This is basically called factor completely. It's take out a GCF and factor again. So if I took out a 2, which is the GCF, I would then notice that this meets my criteria of perfect squares, x minus 4 and x plus 4. And then don't forget the GCF that you did all the way back in the beginning when writing your answer. So the next one has a GCF of 3. And then factors of 36 that add up to 12 would be 6 and 6. So I get P plus 6, P plus 6, and don't forget the GCF all the way back in the beginning. Now, if you wanted to write this as 3 and then P plus 6 quantity squared, that would also be appropriate. All right, the next one. I could take out a 2. Now, I'm going to do guess and check for this one. So 2n and 2n are 2 factors of 4. -3 times -3 are 2 factors of 9. And so you'll notice the theme of today is kind of that everything's going to be a perfect square. And there it is. It adds up to the middle. Next one, they're both divisible by 10. Again, don't be alarmed that they're out of order. I realize that most of the time we always want to factor something that is in standard form. But if it's a binomial, 7 and 7, a positive x, and a negative x. So perfect square for 49, perfect square for x. Fractional ones. Now, anytime I'm solving with fractions, usually I get rid of the fraction by multiplying everything through by the common denominator. But what they were trying to show you is that 1/3 times 1/3 makes 1/9 and also adds up to 2/3. Now, how do I solve? Anytime something is in factored form, set the parentheses equal to 0. I didn't need to set it to equal 0 twice because it ends up being the exact same parenthesis both times. So again, it does meet the pattern here. If you 49/36 is 7/6 and 7/6. So that is basically breaking it down into its perfect square. Now, many of you probably don't know this, but -7/6 plus -7/6 adds up to -7/3 because you get 14/6, which reduces. So once it's in factored form, set the parentheses equal to 0. We will not test you on this question. We're not going to make anybody actually deal with the fractional portion, but it is on your homework assignment just for good practice with fractions. A bird picks up a golf ball, drops it while flying. The function represents the height, y, of the golf ball t seconds after it was dropped. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit the tree? So here it is. So 81 minus 16t squared. Now, what they want to know is, what if it hits a 36-foot high pine tree? So 36 for y. So how long would it, I'm going to subtract 36. I apologize, it's 32, not 36, which is, I looked up, I'm like, wait a minute, that's not right. Subtract 32. So I get 49 minus 16t squared. These are perfect square binomials. So I get 7 minus 4t and 7 plus 4t. And then how do I solve something in factored form? I set the parentheses equal to 0. So -4t equals -7. Divide by -4. T is equal to 1.75. And this one, subtracting 7. Now, this time you get a negative number, -1.75. So that one's not possible. So it's going to take 1.75 seconds for the golf ball to hit the top of the tree. Now, the next question says, how many seconds does the ball to hit the ground? So now, instead of 32, we're going to put in a 0 for y. So again, these are perfect squares. So perfect square binomial with a minus sign in between. Once you have something factored, set the factors equal to 0. And so for it to hit the ground would take 2.25 seconds. This one ends up being a -2.25, and you can't have a negative amount of time. So again, the eagle with the golf ball, if it's going to hit the top of the tree, it's going to take 1.75 seconds, and if it's going to hit the ground, it's going to take 2.25 seconds. Now we're going to do what we just did, but we're actually going to solve as well. So it probably should have been done, this probably should have been done beforehand. This is a perfect square binomial. So x squared minus 9. So I'd have x minus 3 and x plus 3. Once I have it in factored form, set the parentheses equal to 0 and solve. So the next one, 2n plus 5 and 2n plus 5. So I did guess and check. So I guessed the factors that make 4n squared, and I guessed the factors that make 25. Now, when I go to solve this, I actually don't need to do it twice because it ends up being the exact same answer twice, which actually means something when you get into graphing, but doesn't necessarily mean anything right now for you guys. When we do solve by graphing, that would actually matter. I don't want a negative in front, so I'm going to move everything to one side so that it equals 0. So I'm going to add 2w squared, and I'm going to subtract 28w so that everything's on the right-hand side instead of the left-hand side. There is a GCF. Anytime there's a GCF, you should take that out. Factor. So I need factors of 49 that end up being negative 14, which is negative 7 and 7. Now, when I go to solve this, I know you're normally going to set the factors equal to 0, which is true, but you only need to set the factors that have a variable equal to 0. So even though 2 is considered a factor of the problem, it is not a variable factor of the problem. So therefore, I don't need to set that one. And this is the same one twice, so I don't need to do it twice. So the last one, and this one's on the test, it's got a GCF. So I need to take out the GCF first. Different squares, right? So p squared and 36 are both perfect squares, so one's plus and one's minus. Set the factors equal to 0. And again, I don't need to set the 5 to 0 because it's not a variable factor. So summary of what you're going to do. 1, always do the greatest common factor first. That is numero uno. First thing that I always ask everybody, is there a GCF? Second, look to see if it's a trinomial. Look to see if it's factorable. Look to see if it's perfect squares. So again, just look to see what it can be broken down in, and we've learned a lot of different methods of what we can do when we go to factors. So the last one here, go ahead and try this one by yourself. All right, welcome back if you hit the pause button. So now I took out the GCF, and I saw that this is 2 perfect squares with a minus sign, so x minus 3 and x plus 3. And notice that I didn't forget the 2 out in front. So homework assignment is out of the book. Please double check that with your teacher. If you have any questions, talk to your teacher, and good luck.